between two parallel currents. To find the force on the current carrying wire due to a second current carrying wire, first find the field due to the second wire at the side of the first wire. Then find the force on the first wire due to that field. We have two very long wires. One is IA, one is IB. They are parallel in same direction. Now I want to find the force acting on this wire. We call it FBA. The force acting on the B by A. First, we found the magnetic field B at point produced by IA. With the IB, the field produced at line B by IA is I air cross B. Okay, what is B? So we put this one down. I air is this one. B is produced by I1 is by right hand is downward B. BA due to IA. This is one. So we see this I air cross B, we get FBA is direction towards the Y1. Equal to IF, this is perpendicular, sine 91, BA. BA is mu 0 IA, 2 pi d. D is the distance between two wires. Okay? All right? And we put it together, we get the mu 0 IB IA 2 pi d. Same reason, the force acting on BIA produced by YIB is VB. By right hand row is going up this arrow. So IA air cross B is towards this one by right hand row. Okay? IAB equal to IA air cross B. We find this one, we get this IB. Okay, so they are the same. We can imagine that Newton's third law of pairs. Okay, they are equal in magnitude and opposite in direction, acting on different objects, never cancel out. So parallel current attract. You see these two? They attract. If they are current are anti-parallel current, then we repel with each other.
This set of wires is hooked together so that current can flow through each wire in the same direction. When we set the currents flowing in the wires, they pull together. In this set of wires, 3 of the currents flow in the same direction, while the other 3 currents flow in the opposite direction. Each set of 3 wires pulls together, but the 2 sets repel one another and remain separate.
The force acting between currents in parallel wires used to be the basis for the definition of the ampere, which is one of the 7 metric system base unit. The definition adopted in 1946 it is the ampere is that a constant current which if maintained in 2 straight parallel conductors of infinite length of negligible circular cross-section and placed 1 meter apart in vacuum would produce on each of these conductors a force of 2 times 10 to the minus 7 Newton per meter of length. This is very hard to measure, okay? So we have redefined it. Later definition, effective 2018, May 20. 1 ampere is equal to 1 coulomb, or 6.241509074 times 10 to the 18 electrons worth of charge, moving past a point in a second. Rain gun. this is called a rain gun. You see the connection, the current comes here, and so the conducting fuse here go back from here. Okay, this is a projectile. Okay, this is a fuse, conducting fuse. Is gas. Okay, now what we do when we apply the current goes so this conduct gas go back, so it produces huge magnetic field B into the cross. We use the right hand rule, we can find the B. And since you have a current here, you have in the magnetic field B, you get a force. The IDS cross B is this direction. So this force push this one called project away. Okay? When you have to use very hard in military. The V is 10 kilometers per second. The acceleration is 5 times 10 to the 6